In this video, we will be explaining the logic behind the projectile motion of an object launched horizontally and how to make some calculations relating to it. If I am standing on the edge of a cliff with two balls and I throw one ball horizontally and drop the other straight down, which will hit the ground first?
Well, I would assume that the ball dropped straight down would hit the ground first, because all of its time is spent going towards the ground. The ball thrown horizontally goes further away, so it should take a longer time, right?
Good guess, but the two balls will actually hit the ground at the same time. This is because perpendicular components of a vector do not interfere with each other. Take a look at the forces of the balls. Both of them have the same acceleration due to gravity, and the throw has an additional horizontal velocity perpendicular to the acceleration. And in physics, two perpendicular forces can be applied to an object without making either of their effects smaller. So the horizontal projectile will still accelerate at the same speed downwards, even though it will move horizontally. Thus, it will hit the ground at the same time as the vertical projectile.
Oh, okay. So now that we understand that horizontal projectiles still accelerate downwards at the same speed, let's talk about how we can calculate different variables on a horizontal projectile path. For calculating all of these, it's a mere matter of knowing equations. The first important equation is vertical distance traveled equals 1/2 acceleration times time squared. Let's try it out on a problem. If I'm 2 meters tall and I throw a football horizontally at 25 meters per second, how far will it travel before it hits the ground? This problem requires us to find both the time it is in the air and the distance it travels in that time. First, to find the time before impact, we can tweak the distance equation and solve for time. After making the calculations, we get the equation time equals square root of 2 times distance over acceleration. And remember, the ball falls from my 2 meters in height at the same rate regardless of the fact that it is traveling horizontally. So we can just insert the variables into the equation to find the time it takes to fall 2 meters. So time equals square root of 2 times 2 meters high divided by 9.81 meters per second, the acceleration due to gravity, which equals about 0.41 seconds.
Now that we have the time, we can figure out how far it travels during that period. To find horizontal distance, we multiply the horizontal velocity by the time it travels before hitting the ground. Makes sense, right? So we insert the variables into the equation. So the ball goes at 25 meters per second for 0.41 seconds, which equals a horizontal distance of 10.25 meters. So the ball traveled 10.25 meters before it hit the ground.
Now let's move on to solving for horizontal velocity with a new problem. If a cannonball is fired off the top of a 100-meter cliff and landed 200 meters away from the base, how fast was it fired?
We know that the equation for horizontal distance is horizontal velocity times time. So if we divide the horizontal distance by the time, we can solve for velocity. Now, since we know the horizontal distance, 200 meters, all we need to do is find the time it took for the ball to hit the ground. You know how to solve for time using the equation t equals the square root of 2d divided by a. So pause the video, solve it on your own, and resume it when you're done. Alrighty then, let's see if you did it correctly. Insert the variables into the equation to get time equals the square root of 2 times 100 meters divided by the acceleration due to gravity, 9.81 meters per second, and this equals about 4.52 seconds.
Now we can plug that time into the equation and divide to find the velocity. So 200 meters divided by 4.52 seconds is about 44.25 meters per second. So all in all, now you know that horizontal projectiles still fall downwards at the same rate as drop projectiles. And you also learned how to solve for horizontal velocity, horizontal distance, and time in air using the following equations. Time equals square root of 2d over a, and horizontal distance equals velocity times time.